Okay, now that our Arduinos are working, it's time to learn a little bit about how these work and what we're up to. First off, this is the Arduino board. We're using the Arduino Uno. Some of you guys might have one of the SparkFun boards, which are pretty much the same, just a copy of that. And the ones we use have a built-in microcontroller, and which is pretty much a complete computer, as this graphic says. It's got CPU, RAM, flash memory, input, output, all in a single chip. So it's something we can have a lot of control over. You guys have seen these jumper wires or cables. They're pretty much all the same, except the color coding is just to help you out. So the colors themselves don't have anything to do with the capacity of what they can carry or any functional aspects. Now the breadboards, there's two types. Most of you have the smaller one like this. And if you take a look at the back here, this is what it's doing. It just connects, helps connect circuits. So if you were to plug something into this hole, all of these on this row would be able to tap into that, say, power source or whatever signal is going through there. Now the larger ones are just pretty much the same, a little more complex. We have the same rows all the way through that do the same thing as the small breadboard, but the addition just have these power strips on the side. So often you would run the power from the Arduino, positive here, your ground to the negative, and then there's a ton of pins that you can then access if you had more power needs than with the small one. Internally, they have some sort of pinch pins inside. They'll pinch and hold the pins. So sometimes you have to make sure they're well seated in when you have your jumper cable to make sure that connection is working. Now let's take a look at this circuit. First we'll look at the left one here. This is like what we did yesterday. We have a ground and we're getting power out of 13. The way the circuit works, comes up here into the breadboard, and then this whole row is active, hits this resistor, which transfers the power over to this row, and then in this row we have the LED tapped in. So the positive leg would be right here, lights the LED, the energy, electricity travels back down this way and then goes back to ground. That completes the circuit. If you notice this one on the right hand side, we have our positive and negative wires up through this adapter, or excuse me, resistor up here, and the circuit isn't complete. This is a button. We'll be using this today. Up here there's nothing connecting the circuit. We'll end up adding a LED there as well. But the circuit can then jump back through, down here, and back to ground. Alright, let's review the blinking project that we did last time. Here was the setup. We had pin 13 connecting to the positive row where our LED was, and the negative row from the LED connects to the resistor, and this is using the large breadboard. So notice these long strips offer the positive and negative. So that's why they're connected here, because then it provides power this whole way up and then runs back to ground and 9 volt. So more specifically, this is what the circuit schematic looks like. If any of you guys are taking some of Mr. Wilson's physics classes, you probably have seen these. So we have the Arduino, the LED, the resistor, and then ground. If you don't know why we go to ground, that's something to Google. We can talk about that also next class. Now the code itself is based on processing language, which is a starter language, so it's much easier to use than Java because it's a simplified version of it. This is what the code looks like, and it was in our example files. And what this one does is a blink sketch. A sketch is what they call programs in Arduino. It sends a high signal, so right there we see high, which sends the 5 volts on pin 13. Then it waits 1,000 milliseconds or 1 second, and then it changes it to a low signal, which is the equivalent of turning it off. So that's how it turns off and on, off and on. Now what's cool about this is there's only 2 built-in methods. The setup method that runs when we start up the Arduino, power it up, or hit the reset button. So if we jump back to the very beginning, notice there's a reset button on all of these. And then once the program is running or your sketch is running, it's just going to continually loop until it's powered off or reset. You can look up the API here at this URL. So we have our setup one that's setting up pin 13 as an output pin. The only other option we'll see today is that it can be input. And then we have our loop that's just going to continue. We're going to send power through through line 13, delay, then we're going to turn the power off over and over and over. That's what makes it blink. All right, so here's that graphic I showed you a few minutes ago about a complete circuit on this side and an incomplete one. Let's build this, and we're going to end up throwing an LED in right here that we're going to control by the button to turn it on and off. And here's a couple questions to think about. Can this resistor right here be removed? If so, what effect would it have? And along with this one, what effect would that have, perhaps? And then notice that this one has 3 cables, whereas this one doesn't. So try to think about why that is the case. And here's the code for this next one when we get this working. So we have one light coming out of pin 13, and then we have to activate pin 2 as well. But this one is available in the examples, so you don't have to type it. And that's it.